Hello and welcome to video 6 for Math 123. In today's video, or in this video rather, we're going to be looking at solving systems of linear equations, which is basically two equations with two unknowns, and then also solving linear inequalities. So, to solve systems of linear equations, we have three options. Option 1, graphing. Now, the problem with this one is that it's extremely inaccurate. If you're drawing the graph yourself, you're probably not going to have it super accurate. Even if it's on a computer, trying to pick out that exact point might not even be possible. So we don't really use this one too much. You'll see problems with it, and the solution is quote-unquote obvious. But for the most part, we're not going to be using this method. We're going to be either using substitution or elimination. So depending on the equations we're given, sometimes substitution works better, sometimes elimination works better. Either method will work any time, so whatever you're most comfortable with, I would say go with that route. So let's look at an example. Let's say we want to solve for x and y. And our first equation is x minus y is equal to 4. And the second is x plus 2y is equal to negative 5. So with substitution method, what we would do is solve one of these equations, say that x equals something or y equals something, and then plug that into the other equation. In this case, it would work because we have just x by itself and just y by itself. But if we end up with an equation that has a bunch of coefficients, remember that's the number in front of the variable, so a bunch of coefficients that aren't 1, the substitution we'd be making, we'd probably end up with fractions, and the problem's going to get real messy in a hurry. And so in that situation, we would do elimination. And I'll show you guys one of those problems next. So what I'm going to do, so we can keep track, let's call this equation 1 and equation 2. So equation 1, I'm going to move the x over and get just y by itself. So if I do that, what do I have to do? So let me switch colors here for you guys. I'd have to subtract x from both sides. Remember, it's like the teeter-totter. A few videos ago, we talked about solving linear equations. So when I do that, on the left side, the x's are gone, so I have just minus y, so be careful with that negative sign, is equal to 4 minus x. But I don't want minus y equals something, I want y equals something, so I can plug it in here. So what do I have to do? I have to divide everything by negative 1. And when I do that, I get y equals negative 4 plus x. So all I did there was solve that equation to get y by itself. You could have gotten x by itself and just added y and then substituted in for x. Either way is okay. But here I solve for y, so I'm going to plug that into the second equation and rewrite this as x plus 2 times y. Well, y is negative 4 plus x is equal to negative 5. Now what do I have? I just have one equation with one unknown. So distribute your 2. So 2 times negative 4 is negative 8. 2 times x is 2x is equal to negative 5. Combine our like terms. So 1x plus 2x is 3x. Minus 8 is negative 5. What do we want to do here? Add 8 to both sides. That way they're gone. We get 3x. Negative 5 plus 8 is a positive 3. Divide everything by 3 to get x by itself. 3 divided by 3 is 1. So we get x equals 1. But we want to solve for x and y. So we need to plug it, you can either plug it back into one of your originals, or we have over here y is negative 4 plus x. So if I plug that in here, y is equal to negative 4 plus x, which is 1. Negative 4 plus 1 is negative 3. So therefore y is equal to negative 3. And you can test your answers here. Plug them back into the original. You can check them. If I plug 1 in here, that's 1. Minus a negative 3. Well, minus a negative 3 is plus 3. 1 plus 3 is 4. That one works. How about here? Well, 2 times y, which is negative 3, so that's negative 6, plus 1 is negative 5. So now I'm 100% sure that the answers that I solved for are correct. So that's how you would solve a system with substitution. What if we don't get a nice equation like we had there? So let me switch my markers here. I'm a little low. So let's say we want to solve for x and y, and I have 2x plus 3y equals 4, and 5x minus 6y equals negative 17. So again, let's call them 1 and 2. So unlike the last one, we don't have x or y by itself. So if I tried to solve for x, I'd get a fraction. If I tried to solve for y, I'd get a fraction in either equation. So the idea of what elimination is we can get the coefficients of one of the variables to be opposites of each other. So 1 and negative 1, 2 and negative 2, etc. Then we can just add the equations and that term will disappear. So to do that, let's look at the y term. So in the first equation, I have positive 3y. In the second equation, I have negative 6y. So how would I be able to get these to be opposite? Well, if I multiplied this first equation by 2, this would be plus 6y. And in that case, these two would cancel each other out. So as long as I multiply the entire equation by some number, in this case I'm going to multiply it by 2, so that when I multiply that by 3y, I get positive 6y, which will cancel out, then it's okay. Because think about it, if I have, 5 is equal to 5, that's true. If I multiply everything here by 2, I get what? 10 is equal to 10, so that's okay. But the key again is make sure you are multiplying everything by that number. So if I do that, what does this give me? 2 times 2x is 4x. 2 times positive 3y is plus 6y. 2 times 4 is 8. And the second one I'm going to leave alone, because it already has the opposite value I need. So I have what? 5x minus 6y equals negative 17. So now what I'm going to do is add these two equations. So 4x plus 5x is 9x. 6y minus 6y, these guys cancel each other out. That's the elimination part of this situation, equals 8 minus 17 is negative 9. So divide both sides by 9 to get x by itself. Careful with your negative signs. X is equal to negative 1. So now plug this back into either of these equations. I'll just use the first one. So I get what? 2 times x, which is negative 1, plus 3y is equal to 4. 2 times negative 1 is negative 2, plus 3y is 4. Add 2 to both sides. We get 3y is 6. Divide both sides by 3. Y, those cancel out, is equal to 2. So our answer for this one would be x is negative 1, y is equal to 2. And again, if I went through anything a little bit quick, feel free to pause, rewind, watch it again, ask in class. That's the whole idea behind this method here. Alright, so that's solving systems of linear equations. We had the equal sign, therefore it becomes an equation. We also have linear inequalities. So inequalities is the umbrella name for less than or equal, greater than or equal. So we're going to solve them essentially the same way as linear equations. However, solving linear inequalities just make it a big star here. When we're doing this, if we multiply or divide by a negative number, we must reverse the inequality. So that is the only difference that we're facing here in terms of the process. So we still can add and subtract numbers, we can still divide by numbers or multiply by numbers. The only thing we have to be careful is if we multiply or divide by a negative number, we have to reverse the inequality. So let's look at an example. Let's say I want to solve for x, and I have, I guess I don't have that yet. So the example I wanted to give here, sorry. So we're not solving for x. Let's say I have -1 and 4. So the inequality would be what? -1 is less than 4. And so the reason I have to switch this, that's what the point I'm trying to make here, is if I multiply both sides by -1, what happens to these numbers? -1 times -1 is +1. 4 times -1 is -4. So now 1 is not less than -4, 1 is greater than -4. So that's a simplistic way of showing you why do we have to reverse that inequality. We're changing the side, which essentially does what? It flips it on the number line. So we have to be careful there. All right. Yes, we will solve one here in a second. So graphing inequalities. So when we solve linear equations, we're just getting one point. X is equal to -1, or y is equal to 2, or whatever it might be. But inequalities are saying greater than or less than, greater than or equal to, less than or equal to. So it actually covers a whole range of numbers, not a specific point. So our notation for this, so when graphing inequalities, on a number line, if the point is included, so for example, if it's x is greater than or equal to 4, so 4 is included, then we use a closed circle or a colored in dot. If not included, so let's say we just have x is greater than 4, so it doesn't include 4, it's only greater, then we use an open circle. That's our indication that it's not included. Is included, not included. Let's look at an example. Let's say I want to graph x is greater than or equal to 3. So this means what? 3, 3.5, 4, 5, 6, 7, 8, everything. Everything up past 3 is what this notation is talking about. So on a number line, my point is at 3. Is it included? Well, x is greater than or equal to 3. So yes, it's included. So I use a closed circle. And it's what? It's everything going up to infinity. So that's how I graph inequalities. Is the point included? Yes, it is. So it's a closed circle. And it's going everything greater than 3, so everything towards infinity. And what if I have the following? Let's graph less than 1. So again, I draw my number line. The point of importance here is 1. Is 1 included? X is less than 1. So no, it's not included. It's not less than or equal. It's just less than 1. So that means it gets an open circle. That's my indication. Hey, this number is not included. And less than 1 means it's everything going towards negative infinity. 0, negative 1, negative 10, negative 100, etc. All right, so that's sort of our notation, the math we have to be careful with. So let's go ahead and work one of these problems. So let's solve and graph 2x plus 4 is greater than or equal to 10. So I want to know all the numbers out there that if I plugged it into this inequality, make it true. So again, I'm going to just follow normal equation steps. So 2x plus 4 greater than or equal to 10. First thing I need to do, get the variable piece by itself. So I need to subtract 4 from both sides. Now it's okay to subtract a number without changing the sign. The only time we have to worry about a negative number is if I'm multiplying or dividing by a negative number. But if I'm just subtracting it, that's fine. So the 4's cancel out. I get 2x greater than or equal to 10 minus 4 is 6. Now to get x by itself, divide everything by 2. It's positive, so leave the inequality alone. I get x, 6 divided by 2 is 3. So my answer is x is greater than or equal to 3. So let me graph this. We already kind of did with our example, right? But it's at 3 is my point of importance here. Greater than or equal, so it's included. And because it's greater, it's everything going to infinity. Now, you were able to check your linear equations by doing what? Plugging in your answer, see if it worked out. You can kind of do the same here, but because we're talking about a whole range of numbers, first of all, pick this point that you're saying is where we start, 3. If I plug 3 in here, what happens? 2 times 3 is 6. 6 plus 4 is 10. Is 10 greater than or equal to 10? Yes, it is. It's equal. So that point should be included as we've indicated. Let's pick another point. Well, we're saying we're out here on the right, so let's just pick 10. It's an easy number to deal with. If I check 10 in here, 2 times 10 is 20, plus 4 is 24. Is 24 greater than 10? Yes, it is. So I can feel pretty good that the picture I've drawn here is the likely answer for this linear inequality. All right, so that does it for our system of equations. We are basically going to be using 2 methods, substitution, elimination. And then solving inequalities, the important thing there is make sure that you reverse the inequality symbol if you multiply or divide by a negative number. So come on back and we will wrap up the videos for our functions and algebraic thinking section.